welcome you all. We shall solve this problem. Here the problem is a finite series. Here is given a finite series which is n equal to x over 1 minus x square plus x square over 1 minus x4 plus x4 over 1 minus x to the power 8 plus dot dot x to the power x to the power 2 to the power n minus 1 over 1 minus x to the power 2 to the power n. We have to prove this sum of this finite series is this. Sum of this finite series is this, which is x into 1 minus x to the power 2 to the power n minus 1 over 1 minus x into 1 minus x to the 2 to the power n. This is the sum of this finite series. We have to prove it and also find the limit of n at n tends to infinity. Limit n tends to infinity, n is to be found out. Now, at first, now let's start the solution. At first, we write the sum which is to be proved n equal to x into 1 minus x to the power 2 to the power n minus 1 over 1 minus x to the power n. We take two observations for n equal to 1 and n equal to 2. For n equal to 1 and n equal to 2 is true for this is true for n equal to 1 and n equal to 2. We have to prove at first. Take two observations. For n equal to 1, a1 equal to x minus x square. If we multiply both numerator and denominator by 1 minus x, we get x into 1 minus x, 1 minus x into 1 minus x square. That is x into 1 minus x to the power 1 minus 1 over 1 minus x into 1 minus x to the power 1. So we can see that this is true for n equal to 1. This is n equal to this is true for n equal to 1. Next we take n equal to 2. N equal to 2, a2 equal to here we can write a2 equal to x square over 1 minus x to the power 4. If we factorize these terms, these expressions, we get x over 1 minus x square into 1 plus x over 1 plus x square equal to x into 1 plus x square over 1 minus x to the power 4. Again, if we multiply the numerator and denominator of these expressions, we get by 1 minus x, we get x into 1 minus x, 1 plus x square over 1 minus x into 1 minus x4. This is we multiply the numerator and denominator by 1 minus x. So this can be also written as x into 1 minus x cube over 1 minus x into 1 minus x to the power 4, which is also can be written as x into 1 minus x to the power 2 to the power 2 minus 1 minus x into this. So this is also true for n equal to 2. Here you can see this is true. This is n equal to this is true for n equal to 2. So two observations, we have to take two observations, n equal to 1 and n equal to 2. For two observations, n equal to this is true. Now let us assume this is true for so A1, A2 is true. Now we assume AM is true. Assume AM is true. We assume AM is true, and we have to prove AM plus 1 is also true. That is, for n equal to AM, for n equal to AM is true is assumed, and we have to prove for n equal to m plus 1, that is m plus 1 is true. Now we have assumed m is true, so m we can write m equal to x into 1 minus 2 to the power m minus 1 over 1 minus x 1 minus x to the power 2 to the power m. This is true. We have assumed. We have to prove m plus 1 is also true. That is, for n equal to 1, for n equal to 1, this expression is true. We have to prove. Now, for n equal to m plus 1, that is m plus 1, m plus 1 equal to, we can write m plus x to the power 2 to the power m plus 1 minus 1 over 1 minus x to the power 2 to the power m plus 1. That is, m equal to, we have assumed m is true. That is, for n equal to 1, m is true. That is, this expression is true for n equal to m. So m equal to x into 1 minus x to the power 2 to the power m minus 1 over 1 minus x 1 minus x to the power 2 to the power m plus x to the power 2 to the power m 1 minus x to the power 2 to the power n plus 1. Now, m plus 1 equal to, we can factorize this expression, and after factorization of this expression we get x over 1 minus x to the power 2 to the power m into 1 minus x to the power 2 to the power m minus 1 over 1 minus x plus x to the power 2 to the power m minus 1 over 1 minus 1 plus x to the power 2 to the power m. This is, we have factorized this expression and we get this. That is, m plus 1 is this. So, we can write 1 minus x into 1 plus x to the power. We take the sum of these two terms. We take the sum of these two terms. We get 1 plus x to the power 2 to the power n, 1 plus minus x to the power 2 to the power m minus 1 minus x to the power 2 to the power m plus 2 to the power m minus 1 plus x to the power 2 to the power m minus 1 minus x to the power 2 to the power m. That is, these two terms is cancelled out. Also, these two terms is cancelled out. After cancellation of these terms, we get x over 1 minus x into 1 plus x to the power 2 to the power m into 1 minus x to the power 2 into 2 to the power m, that is 2 to the power m plus 1 minus 1, also minus 1 using the power of x. So this is, and also we can write x into x to the power 2 to the power m plus 1 minus 1 over 1 minus x into 1 minus x to the power 2 to the power m plus 1, and this is m plus 1. So we can see that this n equal to this is true for n equal to m plus 1. That is, m plus 1 is also true. So am plus 1 is also true. This is the process of induction. So we have proved by process of induction, the method of induction, that we can say by this method of induction that n equal to x into 1 minus x to the power 2 to the power n minus 1 over 1 minus x into 1 minus x to the power n is true, is true for all natural number n. This is true for all natural number n. That is, n equal to this is true for all natural number n. So we have proved this sum of this finite series. Sum of this finite series is n equal to this. We have proved it. Now next, we have to find out the value of the limit n tends to infinity n. Already we have got the value of n, that is sum of this finite series, and finite series, sum of the finite series is this, and we have to find out the limit of n at n tends to infinity. That is, we have to find limit n tends to infinity n. Now next we find the limit. We shall find the limit n tends to infinity n. Limit also limit n tends to infinity n equal to limit n tends to infinity x into 1 minus x to the power 2 to the power n minus 1 over 1 minus x into 1 minus. Here two cases arise. The two cases are mod x greater than 1, mod x less than 1. For these two cases, what will be the value of these the limit of n at n tends to infinity. We have to find out. And also for x equal to 1, this is undefined. So for x equal to 1, the limit cannot be attained. We have to check the limit n tends to infinity n for mod x greater than 1 and mod x less than 1. For mod x greater than 1, limit n tends to infinity x over 1 minus x into 1 minus x to the power n minus 1 over 1 minus 2 to the power n. For mod x greater than 1, limit n tends to infinity n equal to x over 1 minus x, limit n tends to infinity. We can divide the numerator and denominator of these expressions by x to the power 2 to the power n minus 1. We get 1 by x to the power 2 to the power n minus 1 minus 1 over 1 to the power n minus 1 minus x. Now as mod x greater than 1, so we can write limit n tends to infinity 1 by x to the power 2 to the power n minus 1 equal to 0. So limit n tends to infinity n equal to x over 1 minus x into 0 minus 1, 0 minus x, which is 1 by 1 minus x. So limit of n at n tends to infinity for mod x greater than 1. If mod x greater than 1, limit will be 1 by 1 minus x. The limit of n at n tends to infinity will be 1 by 1 minus x. Now we check for mod x less than 1. For mod x less than 1, limit n tends to infinity n equal to x over 1 minus x, limit n tends to infinity 1 minus x into 1 minus x to the power 2 to the power n minus 1 over 1 minus x this 2 to the power n. And also for mod x less than 1, if mod x less than 1, we can say limit n tends to infinity x to the power 2 to the power n minus 1 equal to limit n tends to infinity x to the power 2 to the power n equal to 0. Since mod x less than 1. If mod x less than 1, these two limits will be 0. So for mod x less than 1, we can get the limit n tends to infinity equal to x over 1 minus x into 1 minus 0 over 1 minus 0. That is x over 1 minus x. So there are two limits we have found out for limit n tends to infinity n. For limit n tends to n, we have got the two values. For mod x greater than 1 and mod x less than 1. When mod x greater than 1, the value of the limit is 1 by 1 minus x, and for mod x less than 1, the value of the limit is x over 1 minus x. Also, for x equal to 1, the limit does not exist, because this is for x equal to 1, this limit is undefined. So, we have got two values of limit n tends to infinity n, for one for x mod x greater than 1 and other for mod x less than 1. For mod x greater than 1, we have got the limit n tends to n infinity n equal to 1 over 1 minus x, and for mod x less than 1, we have got the limit n tends to infinity n equal to x over 1 minus x. So these two limits are found out. So limit n tends to infinity n equal to 1 over 1 minus x whenever mod x is greater than 1, and limit n tends to infinity n equal to x over 1 minus x whenever mod x less than 1. So we have got two limits of n at n tends to infinity for two conditions. One condition is mod x greater than 1, another condition is mod x less than 1, and also for x equal to 1, the limit does not exist. Thanks for watching this video. See you next.